This is Oak Norton, Director of Agency-Based Education, an educational nonprofit organization that promotes principles of free will education. And I'm going to be doing this podcast with a gentleman named Dean Sessions. Last Friday, I went to a fascinating presentation near my home that was mind-blowing because of how it is such a different model of the sciences and the things that I grew up with, and it really shocked me and presented such a different look that I thought, I've got to get in touch with the person behind this and not just one of the individuals out there presenting that's worked on it. And so I had reached out to Dean, and he agreed to do this podcast. And let me just, before I bring him on, mention that his website is called universalmodel.com, and I encourage everybody to go there and see what he's doing. There are, and we'll get into this in the podcast, but because of the work that he's done for the past 27 years in researching himself and bringing in a team of others to assist with this, they've really had to look at everything that has ever been studied and put forth as scientific fact. Because once you start to change something about one system of science, everything else has to be looked at in light of that new discovery. And so Dean has agreed to discuss a couple of these things. In particular, one of the things that came up Friday night was the universal flood, which blew me away with some of the information that is available to us through this model. And I'm going to go into that in depth with Dean to the extent that we can in a podcast. I also want to direct you again to his website, universalmodel.com. At the bottom of the home page is an event button. And for those of you listening on December 7th when I release this, he's doing a presentation in Las Vegas that night. And in Las Vegas, it'll be at 7 p.m. Pacific time. For those of you in Utah and elsewhere, adjust forward. So in Utah, it's at 8 o'clock. That presentation will be broadcast on his Facebook page. So if you go to his website and go to the very bottom, click the Facebook link, you'll go to that page and be able to watch that presentation for free. If you aren't able to see it then, he's also going to be in Utah in Sandy on Friday night and in Orem on Saturday night. He's traveling around from Arizona, where he hails from. And so, Dean, welcome, and thank you very much for being with me tonight.
Thank you, Oak. Nice to be with you here tonight.
So I want to start off and just let people hear a little bit about your background. How did you get started in this? How did you grow up? Did you want to do this when you were younger? What's kind of your story about how this all got started?
Sure. Well, I was probably like a lot of high school students where, I had an interest in science. Actually, my junior and senior year, I took most of the science classes my school offered and took a lot of AP courses and that type of thing. But I really enjoyed it in high school. However, when I got to college, I had a different experience. It was just very different. I even used the same textbook I did in my physics class, for example. I went to college and to the physics class, the same type of class there, and it was just a different experience. There was much more theory presented. We had very little experimentation, and it just turned me off. I just was really surprised, and so I did end up going ahead and graduating in a science field, but it was not the type of science I was originally planning on. I was a physics major, and I graduated in organizational psychology, but I found out by that time that I didn't have that much interest in it, and so I went into the business arena, and it wasn't until about 5 years after I had graduated that I had a lot of experience already in business fields of real estate, and which led me to doing a lot of research. I had an appraisal company, and you have to learn how to really do research, really detailed. For every appraisal that gets done, you have to research on it. It's very important to come up with the right value. And so these things led me into researching. About 1990, I started researching the archaeology field, and mostly in North America, although I started collecting artifacts from all around and looking at them and researching and getting my hands on them. I had an experience when I was a young child. My dad had 2 arrowheads that he had collected he's from Wyoming in the United States, and I remember holding those as a child and how it fascinated me, trying to envision how these arrowhead points were used. And I knew they were not hundreds of years old, that they were at least probably 1,000 years old, and it was just fascinating. But I had never been able to go out and find any on my own. There's not very many artifacts in Arizona. That's where I'm from. But in many other states in the United States, there's many. Back east, it turns out that there's more artifacts per acre, actually, in states like Tennessee and Kentucky and Missouri than you'll find anywhere else in the world. I have not been able to find anywhere that there's the kind of artifacts that were there. And so this research led me to a lot of areas where the scientists that were involved, there were a lot of things that just weren't fitting, a lot of questions that weren't being answered. And so gradually there were several discoveries that were made. And what ended up happening was I went to a professor, and this was after I had left school. We had a chance to talk a little bit about some of these discoveries I had made. And our discussion just didn't go very far, and I really didn't understand why. Matter of fact, I knew to understand the archaeological strata, or the layers that artifacts are found in, you also had to have a good background in geology. So I had started my geological research, and in that we found that there's also a lot of inconsistencies. And one of the things that was very evident was there was this evidence for this flood, which in historical standards, of course, there's this flood that took place all around the world. But in archaeology today, in modern science, they don't accept the flood that was universal, that we learned about in Noah's time. And so when I started asking this professor questions, he came out and told me literally that there'll never be any physical evidence for a universal flood. And I really remembered that being a turning point, because that's what caused me to all of a sudden start looking. And this led me down a trail over the next, like you mentioned, this was 27 years ago. So it opened up a whole can of worms, and we started looking into one science field, and we started making discoveries, and I started pulling some other researchers in with me. We started looking into more things, and I even talked with some scientists after a while, and one in particular, he was a friend of my wife's family, and I remember asking him, what would you do if you found an important discovery and you didn't have the PhD? Because I had already gone to ASU and I looked into going in to get my PhD in their program there. And I had all the paperwork, and I was trying to decide, should I go into this or not? And I remember asking this one professor what he thought, and he told me something very important. He said, if what you found is true, and it really is important, then it doesn't matter what initials are behind your name. You just need to publish it. Mm-hmm. And that stuck with me, and that caused me to go ahead with my studies without going into the field. And now I look back many years ago, that was, and how different my life would have been if I would have gone into the traditional scientific establishment and gone their route, because I would have been in their box, a black box.
Right.
And that's what we have found. There's so much science that's theoretically based. It's in this box, and it has never been able to come out. So that's what started the universal model.
Yeah, so your I know your research has led you all over the place with every field that you've in this book that you've just published, which I know is just one volume of three, and the other two are coming. The first volume has this picture on page 21 of the universal model, and it covers all kinds of stuff that you're going to go into some depth on throughout these. It covers things like this hydroplanet model, the evolution, the living model, the chemical model, universal flood, time and energy, relativity, the universe. I mean, it's pretty amazing where your research has led you and just how vast this is.
There's a real important reason for that, and that is because a lot of answers that you want to give, for example, what's the origin of weather? No meteorologist will ever be able to tell you where weather comes from until they understand the correct geology. Weather actually comes from a geological factor, and this is explained in Volume 1 of the Universal Model, which was just released back in October of 2016, so just a little bit ago. And what we've done in the very first volume is we have an introduction to the the first 4 chapters go into detail explaining really what the current establishment of modern science is, and then it goes in and shows why there's a crisis and how this can be overcome through the new discoveries found in the universal model. That leads us into the next several chapters, which are all about geology. And we, for the very first time, can understand that the Earth, which modern science teaches us right now, started as if you ever ask the question, why is the Earth a sphere? Why is this globe round? Why is the moon and all the planets round? Well, scientists do know that this spherical shape comes from it being a liquid when it first formed. The question is, what kind of liquid was it? And we have gone in and demonstrate that the current belief that the Earth was hit by meteorites or other asteroids and was this impact planet and had all been melted, that's a theory, and we call these type of theories in the a pseudo-theory. That's a false theory taught as fact. These are new words that we've had to create to be able to explain the problems that we find in modern science. So the Earth being a magma planet coming from magma is actually a false concept, and we go into great detail giving many evidences of why this is the case. And then from that point, we go and explain the rock cycle and how much problems there are with this and how rocks don't come from a melt. If they did, they'd be glass. And we go in and describe this. We actually use experiments for the first time and do a lot of demonstrating in these areas. And then we go in and show how rocks are actually made. And people do not realize this today, but rocks, when we're talking all the minerals that we find on the surface of the Earth, except for some rocks that actually come out of volcanoes, of which lava we can see with our eyes. But that lava actually doesn't come from the magma core that we were all taught in school. If it did, that lava would be radioactive, for example. This is why modern science teaches us the inside of the Earth is hot, is it's supposed to be radioactively hot. We go into great detail explaining that in the why that doesn't work. And then we go into explaining also how the rocks are made, and we use a water model to do this. We actually, when you have the right pressure and temperature in a water model, you're able to create the same kind of rocks that salt comes out of water when it's evaporated. All you have to do is know the right pressure and temperature, and you can create your own quartz-based rock, which is the most abundant rock on all the continents. You'll find quartz is a very primary mineral that's very important, and we go into a lot of discussion on that. And then from the geology, all these new geology aspects, we move on into other areas, such like we mentioned before, the weather. From weather, we're actually moving to age, and we have a completely new explanation and demonstration of why the Earth is not millions and billions of years old. That radiometric dating that has been given us. And for the first time ever, you're going to see the studies back from the 60s and 70s explained and shown why this came from a false idea taught as fact, another pseudo theory. And then we go into fossils, and we show actually how fossils are made for the very first time. And you can't go into any state in the United States. Every state you'll find petrified wood. It's all over the world, and it's found on the surface. And this is not taught in paleontology, and we have an opportunity to explain where fossils come from by doing fossil experiments. That's in Volume 2. Also, the living system. There's 3 systems of the book. The first system is the Earth system. That's the one that's been released right now. It's 825 pages long. The second system is called the living system, and that's where we get into all the things dealing with living things, including human beings and our origin and our history and all of that. And then the third system is the universe system, and this is where we get into the physics, chemistry, and astronomy.
It's amazing. As I sat there last Friday night and watched Rod Meldrum present about, he covered parts of Volume 1, but especially went into some depth on the universal flood. That's one of the things that I want to talk to you about on this podcast. I grew up in a religious home, and I know there's going to be a controversy over this research that you've done among the scientific community, because so many of them don't believe in creationism, a God, a Noah's flood type of event, and yet so many people have found fossils and things at high elevations on mountains that don't seem to be explainable except by maybe the mountains just are getting pushed upward or something over vast periods of time. And so I'd like you to address that a little bit, and then talk a little bit about the universal flood, and maybe start off with the Indonesian tsunami. I'm not sure how you would fit all these things together. Rod did it in a way the other night that made sense to me, how he was presenting it, and maybe you can do the same thing, because I feel a little bit inadequate coming into this interview. I knew I wanted to have you present and talk about this, but I'm not a scientist. I grew up loving science. I haven't had the time, and because I've only had your book for a week, I haven't had the time to digest and understand how all of these things are playing together. And so I just want to kind of turn some time over to you again to explain this process, what your model is representing.
Well, one of the first things I think would be good for your listeners is to understand how important the universal flood is. We actually, in the book itself, because there's these 3 volumes, the second volume is almost completed, and a lot of the third volume is already done too. Total, it'll be more than 2,000 pages. So it's really quite a combination of new science, which we actually state that there's more new scientific discovery in this book than any other science book that we've ever found, which is really significant when you think about all of the different fields of science and the different discoveries over the hundreds of years that we've been involved in modern science, which is probably from the 1820s till now is when it's been called modern science. And the thing that we found, if you go back to Newton, Galileo, and Kepler, these early scientists, they all did experiments. A scientist is by definition, somebody does the scientific research and experiments that are reproducible. And from these experiments, we're able to create new natural law that explains and describes nature in ways that we've never before known. That is what true science is. Unfortunately, modern science has walked away from this. If you ask yourself, when was the last time there was a new scientific law discovered? What would be your answer? In your lifetime, Oak?
Yeah.
In your parents?
Yeah, I can't even
your grandparents?
remember.
No. none of our lives. It's been over 100 years since a significant new natural law has been discovered. So we have to ask ourselves, well, wait a minute. Don't today we have more scientists than 100 years ago? Obviously. Today, don't we have more money going towards science than 100 years ago? Obviously. And today, don't we have more technology than 100 years ago? Much more. So if we have more technology, more scientists, and more money, why don't we have more new natural law discovered today than 100 years ago? The answer is because modern science is not even looking for natural law. Now, I'm talking when I say modern science in general. The modern science, we have a quote in our book. We have there's 2,000 pages, but there's thousands of what we call blue quotes from every major science journal article, pretty much. The journals, we take thousands of quotes out of their books and other articles, because what has happened is they have found pieces of truth all over the place. But when they go to put it, we call them pieces of a puzzle, nature's puzzle. They make this observation or this observation. And it's a true observation. It's real. It's reproducible. But when they take that piece of a puzzle and they go to put it towards the modern science puzzle, it doesn't fit. It doesn't go. And you may say, well, why is that? Well, the reason is this. Modern science teaches that man came from an ape, and the ape came from a bacteria. And the bacteria comes from a chemical, and the chemical comes from a bang, the Big Bang. And the bang comes from nothing. Yes, you and I and everything else came from nothing. That's what modern science teaches. And that's supposed to be logical. We're supposed to be able to reason one with another about that. We all know in our hearts that something doesn't come from nothing. Yet this is modern science's overall big picture. And we go into detail with the scientists themselves quoting just everything I just told you, everything from nothing. And it's well documented in the scientific literature. This is what they teach. So if everything didn't come from nothing, the question is, well, how does it work? Where did it come from? What is the big picture of nature? And that's the purpose of the UM, is to explain that and to show that.
Well,
and the universal flood is...
I was just going to say, like you were saying a minute ago, they can reproduce all these experiments and stuff, but if you're basing it off the wrong piece of rock solid truth, then you're never going to be able to attach that in. It's like having finishing a big engineering project and saying, well, I've got this box of screws over here, or bolts and parts. I don't even know where they fit, but I can do stuff with them. So until you have, and I can see why you had to create the universal model, because once you determined that, hey, we actually have a water core instead of a hot core, everything changes. And so
everything changes. That's exactly right.
You have to go through everything.
Matter of fact, that's exactly what we've had to do. The real key came a couple of hundred years ago. James Hutton was the one that gave us this magma core Earth theory, and from that, this is where they came up with their millions of years, and that was all. The purpose of that was to support the theory of evolution. They needed what we call geological time for species to change in one species to another. But we go into detail showing that the scientists themselves know that there's never been one species that has changed to another, not in the laboratory nor in nature. No one has ever observed this, and we have the quotes from the scientists actually stating this.
So let's
go into detail into that.
Let's get
the real key to all this is that the fact that a lot of the answers, for example, in geology, you don't get them or understand them unless you understand astronomy. And the answers in astronomy will actually, part of that will actually come from biology. The answers in biology, well, we find those out from physics, and then and answers in physics will come from chemistry, and they're all interconnected, and they're truly universal. That's why we go back to Galileo and Newton and Kepler. These scientists studied all of the sciences. They were all the same thing to them, really.
Okay, so let's pull back just a little bit, because I know we're going to be pressed for time, and explain what Rod talked about the other night about the the atomic clock scientists, and the Indonesian tsunami, and what was going on with that?
Well, I actually wasn't at that particular presentation, but I can tell you this. We do have a chapter, it's in volume 3, called the Time Model, where we go in and discuss radiometric dating of rocks. That's actually in the age model. In the age model is where we talk about the dating of rocks, and then the dating of things that were alive is radiocarbon dating. Both those things, for the very first time, we demonstrate where the dating methods that are currently used were never accurate. The scientists knew from the very beginning. For example, we went back to the original articles in 1960 when they took lava, I think it was the island of Hawaii, and of course one flow is supposed to be on top of the next flow, on top of the next flow, and the very bottom flow, of course, is the oldest. And they went and they dated all these different flows. They took samples and they dated them, and of course you should have this progressively younger and younger age as you move to the top. And it turned out, and this is in the actual journal articles, it turned out that the numbers were from minus 200,000 to 2 million to 20 million, back to minus 50,000, 17 million, all over the board, no order whatsoever. And this is the type of thing that was just totally ignored back in the 1960s. And it was out of Berkeley that this was done, 2 geologists and 2 other paleontologists, and they decided, well, we're just going to make these numbers work. So there was actually some deception that took place, and this is all documented in the age model in volume 2. We haven't released that yet, so I won't go into more detail there with that. But the Earth itself is fascinating when we come to understand that rocks really do grow from water, and they crystallize out of water. And once we understand this, and the Earth was a globe of water, same as Mars and the Moon. The only reason we don't find water on the surface of those is that gravitationally it doesn't. There's not enough mass there to hold it, and once it turns into a vapor, it's released into space, and that's why we don't find it on the surface. However, all of the surface topography and everything that we look at, the craters there, oh my word, we have more information about cratering process, and this is critical to understand how the Earth and other planets formed, than you'll find in any other book as in the Universal Model. For the very first time, we demonstrate with scientific evidence that the craters on the Moon, over 99% of them are not impact craters. And the Arizona crater, which is known as the Arizona Meteor Crater, which is the most important crater in the whole solar system, that was the very first one that was supposed to be proven to be an impact crater, actually was not made by impact. We have more scientific evidence on this that you will find in any book ever printed, ever written anywhere.
Wow.
This is really important because it turns out that the age of the Earth, the 4.6 billion year number that you read in every science textbook across the globe, that number came from the so-called meteorites that were found around this crater. And it turns out that those iron, we call them iron ejectites, were not meteorites. They never came from space. And we document this with unequivocal evidence. We have 2 smoking guns. When you read the chapter, you'll find out how this crater was not made by impact, and this completely throws out the original 4.6 billion number that they gave the Earth. It all came from that crater, and they assumed that the rocks came from space. And the amazing fact is, they never did.
Wow. So, okay. Again,
how was that crater made? I should have answered that. It was a steam explosion crater. And it turns out from my house, which is in Phoenix, Arizona, I can take you to 100 craters. And I've been to them all. And it's about a 3-hour drive from my house. And geologists today will tell you all 100 craters are steam explosion craters except for one. That's the Arizona Meteor Crater. And it turns out, well, that one's also a steam explosion. They just don't understand the full process of steam explosion. We actually call it a hydrocrater.
Wow.
And they don't understand impact cratering properly. See, when you have an impact crater as large as the Arizona crater, it's a mile across. We're talking it's a high-speed impact. It's over 10 kilometers per second, much faster than a bullet shooting from a gun or anything. And when you're traveling that fast, it goes through the atmosphere in just a couple seconds. And when it hits the ground, to make that large of a crater, you have to have a very large rock. And it literally doesn't just hit the ground and splat. It creates an explosion like an atomic bomb, which literally moves the dirt so fast and creates such high friction and heat that it not only melts the entire side of the crater, it vaporizes the entire meteorite. This has happened in every single lab experiment was done. So guess how much glass we find in the crater of Arizona crater?
How much?
Oh, none. Not only would the entire crater, the inside, have to be glass, but all the meteorites would have been melted. Guess how many melted meteorites they found around the crater?
None.
And inside the crater? None. They never found one of the meteorites inside the crater. They're actually not meteorites. They're iron ejecta. They never found one inside the crater. They were all found on the outside. And there's a whole number of evidences we demonstrate in that chapter concerning this. This is in the hydroplanet model. And this is in volume 1, so you can get it right now on universalmodel.com. And you can go and you can find that one there. But it's a really fascinating, it's one of my favorite areas is the Arizona crater because it's in my home state. There's so much science in Arizona. Arizonans don't even realize we have the science state of all the United States. We have the most important crater. We have the largest, most beautiful petrified forest in the world. We have the largest and most studied and beautiful canyon, the Grand Canyon in the world. We have the most important fossil and gem and rock show in the whole world in Tucson, Arizona, every February. Just fascinating to have all these. We have astronomically some of the most powerful telescopes in the world down in Tucson. And of course, this is where the UN came from. So we really have a fascinating state in the state of Arizona, and that we went over the entire Colorado Plateau to bring all the geology together for the universal model.
It's a beautiful state too. I've been down there a couple of times. I love the variety that exists down there. So let's get back to the universal flood then. How explain to people how the universal flood happens, because there's so much, it couldn't rain this much to cover the mountains, and
yeah, very good question.
You explain that.
Sure do. For the very first time, we explained the mechanism for the flood, where the water came from. We explained the very year that it took place, 4,361 years ago. Not only the year, the very month. This doesn't come out until you read Volume 2. But we're that detailed. The age model actually goes into detail of, we have a lot of dendrochronology, one of the most correct dating systems available that helps substantiate this. We use DNA dating. We use a bunch of other types of dating methods that correctly date the history of the Earth. But the flood is, let me just first mention this. Once we recognize that for the very first time, there are literally hundreds, not one or two or three or a dozen, but hundreds of pieces of evidence shown in the UN that you can find all over the Earth on the surface, demonstrating that this flood actually took place 4,361 years ago. It changes everything in modern science. All the theories in every field are now altered and changed. This goes all the way back. It was Neptunism and volcanism. There was a debate way back a couple hundred years ago, and we talk a little about this in the book. And the problem is they wanted, the scientists back at that time wanted to move away from the world's history. They didn't agree with the Bible. They didn't want to have that in there anymore. They wanted something else. And so where did they go? Well, they went to all these millions of years, and they had to deny that there was a flood. And today, modern scientists, not all of them, but by their own survey, a large percent of them also deny the flood. And in the book, I won't want to go in that detail right now, but we have their own surveys that talk about their feelings towards all these things. And you'll find that because they denied this and because it actually happened, the flood took place, it's caused a crisis because they can't go there. They can't talk about the truth. They can't talk about the water that's inside the earth. There's so much evidence of this now that we have journal article after journal article showing, and some of them talk about 10 times, 50 times, 100 times more water than that's in the oceans on the surface is inside the earth. Right now, there's moons of Jupiter that have more water in them. NASA's already acknowledging this. It has more water inside these moons than we're saying it's inside the earth. There are planets that have moons that are all made out of water, and they have these fountains that come off these. That's a term called a hydro fountain that is larger than the whole moon. Enceladus is one of these moons that is literally the Cassini spacecraft went there and filmed these fountains of water shooting out of this moon. And how this takes place is detailed in the universal model. And of course, these moons and the heat that's generated in them is not radioactive. There's no magma inside them. They're only 300 miles across. So where did this heat come from? Well, it comes from friction. This is actually how volcanoes are made. They're made from friction in the fault lines. The friction heats the rock up, and that it creates the steam. It's an amazing thing. I start talking about this, I could go on for a year, because volcanoes, the number one thing that comes out of volcanoes is not lava. It's steam, water, steam. And it's 95 to 97%. I mean, this is from the journal articles themselves. And so we have so much evidence showing that the water and the plumbing system inside the earth. In Alaska, they had a earthquake, and the plumbing system was connected all the way down. I think it was in Texas. The same time they had the earthquake there, bingo, here goes the pressure up in a water system down in the United States. And so by Texas, I think it was. So you have these thousands of miles long channels inside the earth that are interconnected. And of course, we see this in Yellowstone with all the geysers. Most people have no idea why Yellowstone geysers are erupting. It has nothing to do with a magma chamber below it that they all want to tell us is going to blow up. They never found magma below there. The reason it's happening is Yellowstone has three fault lines all coming together in the same place, right there in that part of Wyoming. And what it causes is a friction going back and forth. These are the plates that all come together, and that friction, all you need is, when you have millions of pounds of pressure, all you need is one little slip, just a couple inches, and you create tens of thousands of degrees heat. That instantly melts the rock, and guess what it does to the water underneath the ground? It
turns it to steam.
Turns it to steam.
Yeah.
It gives us our geysers.
Yep. So how do you get, so given what you've researched here, that the Earth is basically a giant ball of water and we've got land on the outside of it, how do you get that land submerged and then brought back to the surface in order to have this universal flood?
Good question. Well, first off, the inside of the Earth is not all water. The core is water. On the outside, it's liquid, and on the inside, it's ice. And you can read where the researchers have actually documented under these pressures and so forth that ice will crystallize and iron will not. And they think the Earth's center core magma is iron, and it's not. We give a lot of reasons for that. Matter of fact, the Earth's magnetic field is supposed to come from magma. Guess what happens when you heat a magnet? It loses its magnetism. So you see, these are all, once you find a new truth in nature, it has to be connected to all the other things, and if it is, well, then it'll make sense. And this is the very first time we found the inside of the Earth is not all water, like we're saying. There's a lot of area that's kind of like Swiss cheese. There's aquifers all through the inside of the Earth, and that water is interconnecting all throughout. but the plates are floating. The scientists already acknowledge that they're floating on a liquid. And the liquid obviously is not magma. If it was, what would happen to the oceans when you go deeper and deeper? What would the temperature do?
It'd go up.
As you get closer and closer to a heat source, what happens?
Yeah,
the
absolutely.
temperature increases. Right. Okay. Well, when you go down in the ocean, it doesn't go up, the temperature, it decreases. So, amazingly, when they went to drill for magma, they didn't find it at all. We talk about this Long Valley borehole project, and the deepest, that's a whole project we go into detail. The deepest borehole ever was the Russian Kola hole. We go into great detail talking about that particular project. So back to your question about inside the Earth, the water that's down inside there, the plates are floating. It's kind of like a piece of paper. If you set it on water, it's just going to float there. You can actually put a paper clip on water and float it. If you set it on there very carefully, a paper clip will float on water because of the water tension. So if you imagine a piece of paper floating like in your bathtub, that's really what the crust of the Earth is, because the Earth is 12,000 kilometers across. And so the crust is only 6 kilometers on average over the oceans and 36 kilometers over the continents. So it's very, very small, 1 to 1,000. 1 millimeter out of a whole meter is the width of the crust. And that crust, right now on the equator, is being held out. I can't remember, it's 50 kilometers or about 50 miles. I think it's kilometers. So it's at the equator, it bulges out compared to the poles, the North and South Pole. And that's happening because the Earth spins. You probably remember in physics, when you spin something, it goes out, right? If you have a rock and you're spinning above your head, it goes around. That's called centrifugal force. It's pulled out. Well, that's what's happening, and the Earth is pulled out. The crust is being pulled out right now. By the way, we didn't know this up until about 15 years or so ago, but thanks to GPS satellite, the ground you're standing on right now, in the last 24 hours, went up and down. If you're in North America, in the United States, about a foot. That's right. Everything around you moved about a foot. And you can't see that because everything goes up and down around you. But this is called earth tide. And it's the same thing. We all see the tides of the ocean go in and out, right? Okay. Do they ever stop? Oh. Do they ever stop except the tides? No, they don't. These aren't trick questions. the tides don't stop. Okay, why is that? Because the Earth's spinning and it doesn't ever stop spinning. And we go around in 24 hours, but the moon takes 27 days to go around us. Okay, so when we go around, about 2/3 of the pull of the tide comes from the moon's gravitational force. About 1/3 comes from the sun. So what happens is the waters get pulled in and out from the gravity of the moon and the sun. Well, is water the only thing pulled by gravity? No, of course not. The crust is also. And this crust is being pulled up and down every day, about a foot here. On the equator, it's about 2 feet, the scientists tell us. It just depends what part of the continent you're on. But that constant going up and down is what's generating heat in some of the crustal areas. And this is where the geologists have got fooled into thinking that it gets hot when you go down. When was the last time you went into a cave? Do you remember going in a cave in your bathing suit because it was hot? Oak, have you ever been in a cave?
Yeah, and it's cold.
Oh, you didn't wear your bathing suit, huh?
No.
No, that's right. And so, anyway, we give a lot of different evidences for all these different sciences we're talking about. And the amazing thing is they're, like we said, they're universally interconnected.
So how does...
I hope I answered...
Well,
yes, I'm sorry.
Yeah, so you
Back
get
to
the flood.
Yes, and how did that... Yeah, Let's talk about that. I'm sorry, I get distracted. There's so many fun things that interconnect here. We have the Earth spinning at a very constant rate. Matter of fact, in the time model, it's way more constant than any of the scientists understand. And that's a fascinating thing. That was a chapter I just finished not too long ago, so I would love to talk about it, but it's in volume 3, so we won't. However, what we will say is this, and that is that the spinning of the Earth, the only way that you can cause something as large as the Earth to change, back when you heard in that other presentation that the big earthquake, the Sumatra earthquake that was like a 9.0, it was the largest in our lifetime, in our grandparents' lifetime. That only shifted 30 feet when they went to the bottom of the ocean and found where the shift had taken place, that caused a tsunami, killed about a couple 100,000 people in India, in the Indian Ocean there. Well, it turns out that they weren't even able to measure the amount of effect that had on the Earth. They thought it would make a change here or there, but it was just calculations, and nobody ever took a measurement on it. And the Earth always comes back. There's a reason why that we will explain why the Earth always comes back to the same speed that it's spinning. But the point is that the only way we can change the spinning of the Earth is by having another large gravitational effect on the Earth. And nothing on the Earth is going to change the spinning of the Earth. Everything's just too small. So you have to bring another celestial body by the Earth. And the only way that's going to happen is when we bring in a comet. Now, comets don't travel in a circular motion that the planets are generally in. They're in an elliptical orbit. And so Halley's Comet, most people heard about that one. I think it's about 78 years that it comes around the sun and then will come by the Earth. Well, up until just a couple of years ago, modern scientists, the astronomers, didn't really know that there was long-term comets. We found a comet that's over 12,000 year period. So the 4,000 year ago flood that took place is very within a third of the orbit of this comet. We don't know if this particular comet caused this flood, but one like it had to come by the Earth, because you have to have something large like this come by. It doesn't have to strike the Earth. All it has to do is come by. It's kind of like a top. If you put a top on a table and you start, you spin it, well, it doesn't spin forever, right?
Mm-hmm.
We actually show in the book tops that spin in the air. They float in the air and spin, and use those for really important examples. But when it's spinning either in the air or on the table, why does it slow down? Because of air friction, and the one that's on the table because of the friction touching the table.
Right.
That's why it slows down. If that friction's not there, it'll just keep going on forever. Well, what happens with the Earth is that there's friction in the tidal forces with the moon and the sun, and also when this comet came close by, it caused the Earth to wobble and start to slow down. And when it slowed down just a little bit, that caused the crust on the Earth to now, if you have a rock above your head and you're spinning it around, right, and it's all the way out there, and what happens if you slow down?
It's going to
the
fall.
Rock comes back.
Yeah.
It's going to fall back in, right? So all you have to do is change the speed of the spinning Earth a little teeny bit, and that caused the crust to fall back in, because they're being held out right now with the spinning of the Earth. And when they fall back down, all the water that's under the crust, guess what happens to it?
The fountains break up, and it starts to push out.
Fountains burst, exactly. See, the scientists laughed originally when other folks, especially the creationists, would talk about the 40 days of raining and so forth, because if you talk about the water in the air and all the atmosphere, it's only about an inch that covers all of the continents.
Mm-hmm.
So they clearly understand that, to them it was like, this is ridiculous to even talk about the flood. But now that we have the physical, empirical evidence of all these oceans of water below the crust, and as soon as the crust, this is called kind of like a liquefaction. We actually have large earthquakes when they take place, and we demonstrate this in the book, because we have all these articles that talked about the big one. I think it was in Chichi in Taiwan. Huge boulders came shooting out. We're talking longer than a meter wide boulders came shooting out of hydro fountains up into the air. People saw them. And this is happening on a an entire planet scale, we have pictures of moons of Jupiter and Saturn that have shown these also taking place. So this does happen. It happens in our solar system, and we've documented it. And so when this took place 4,000 years ago, the continents fell, the water covered the Earth, and then when the comet went away, it just all happened within a year's time period. Historically, this is how it's recorded. Then the spinning came back, and of course, when the spinning came back, the continents came back out, and the water subsided. So it was not a very long process, and within this process, all of the current sediment that you find when you walk around that looks like it's been eroded, that was 4,361 years ago. And this is all documented in the Earth system of the universal model.
That's amazing. I know we're running up against the clock here to close this podcast. This is so fascinating, and I'm so glad that you and the others that have worked on this have done this massive amount of research. I can't even imagine how you would have organized all of this content across so many specialties of knowledge in order to put this together. But I know it was an enormous amount of work that took decades to do. And so thank you for doing that.
Appreciate you taking the time and meeting with me. Yeah,
absolutely. So for those of you that are still listening and fascinated by this, I want to invite you to visit. This is Dean Sessions we've been talking with. He's the founder of the Universal Model. His website is universalmodel.com. At the beginning of the presentation, I mentioned that he's got some events going on. Log on to his website and go down to the bottom, and you'll see those events. The one on December 7th, there's a free Facebook broadcast if you happen to listen to this in time. And Dean has also graciously offered anybody listening to this, if you want to purchase the Universal Model Book 1, the digital edition online, which is over 800 pages, he's given a 25% off discount coupon code when you check out. It's just put in ABE for Agency-Based Education, and you'll get 25% off for the next 30 days. So clock's running on that.
25% off forever. So, yeah, the purchase of the book is, a lifetime purchase.
Yes. Yes, it's perfect. Thank you very much. And I think you're coming out with additional offline editions. Right now they have to log in on the website, but you'll have an app or something coming out that people will be able to download as well. Is that right?
Yep, that should be in about a month. That's right. We'll have it. Yes, they'll have apps, so you don't have to be online to be reading it all the time. That'll be happening. We also have printed versions. We are thinking probably March, for sure April. We have the hard copy version will be coming out also.
Excellent.
It won't be too much more than the digital version, so that'll be exciting for that to be coming out. And but right now you can read it on your phone or on your tablet, and your computer, any digital device, and you can search also and everything we've been talking about, see for yourself. We do have an introduction book we're going to be coming out with here also within the next month or two. That just gives it's a 100-page book that gives an introduction to the UM, and it's a minimal cost. And so you'll find that on our webpage. And we're also working on a summary book and a lot of videos. Also, we'll be working on right now too.
Fantastic. Well, thank you so much for agreeing to do this podcast, Dean. I really appreciate it.
Thank you, Oak Norton. It was nice meeting with you today.